Hello students, I'm hoping you're fine today. We've been doing chemistry for quite some time, and today I want us to do some mathematics. And the concept I want us to begin with is relative speed, because most students, or rather many students, find it difficult sometimes. So there is a question here talking about two vehicles, a matatu and a bus. A matatu traveling at 90 kilometers per hour leaves town P at 8 a.m. and later on, a bus traveling at 120 kilometers per hour leaves the same town at 8:30 a.m. At what time will the bus catch up with the matatu? So there's something I want us to understand here, that when two objects are moving and one of them is faster than the other, and they are moving in the same direction, like in this case, the faster one will catch up with the slower one. Looking at this, the faster one is the bus because it is traveling at 120 kilometers per hour, and the slower one is the matatu traveling at 90 kilometers per hour. Even though the matatu began earlier, 30 minutes earlier, the bus will just catch up with it because the bus is faster. So before we try and solve this problem, we have to understand some concepts related to this. Concepts like relative speed. We need to understand what it means. Relative speed is the speed between two moving objects as observed from one of them. The speed between two moving objects as observed from one of them. And how important is this? It helps us calculate how quickly the two objects are getting closer to each other, or how quickly the two objects are moving away from each other. There are two possibilities here, that the objects could be moving in the same direction or in opposite directions. If they are moving in the same direction, the relative speed is given by the difference between the speeds, the faster speed minus the slower speed. If they are moving in the opposite directions, relative speed is given by the sum of the speeds. Now, let's look at this question. Both the matatu and the bus are moving in the same direction because both of them begin the journey from point P. The question is asking us the time at which the faster one will catch up with the slower one. So the first thing we are supposed to do, let us calculate or find the gap between these two vehicles. The gap in terms of time and the gap in terms of distance between them. We've been told that the bus began the journey at 8:30. That means 30 minutes later. So the gap in terms of time is a half an hour, or 0.5 hours. So we write and say time taken by matatu before the bus leaves point P. That is a half an hour, 0.5 hours. Now, distance covered by the matatu in this time, that is in 0.5 hours. will be given by time times speed. And the time covered is 0.5 hours. The speed of the matatu is 90 kilometers per hour. 90 kilometers per hour. So when you work out this one, you are going to get 45 kilometers. So this means that before the bus began the journey, the matatu had already covered 45 kilometers. Or rather, the matatu is 45 kilometers ahead of the bus. That's the first thing you need to understand. Now, let us find the relative speed. The relative speed, we have said, is the speed between two moving objects as observed from one of them. So in this case, we have the matatu and the bus. When you observe from the matatu or from the bus, what is the speed relating the two vehicles? So relative speed, in this case, the bus and the matatu are moving in the same direction because we've been told that they both began from point P. So they are moving in the same direction. So we are going to subtract the speeds, the faster speed minus the slower speed. The faster speed in this case was the speed of the bus, which is 120. The slower speed is that of the matatu, which is 90. This gives 30 kilometers per hour. That is step 2. Now, the distance that we've just calculated here is called relative distance. The distance between two moving objects at a given point in time. So the distance between the bus and the matatu is 45 kilometers. That is the distance apart, or we can just call it relative distance. So for us to find the time taken by the faster vehicle, in this case the faster vehicle is the bus, the time taken before it catches up with the matatu, you are going to take distance apart divided by relative speed. That one gives you the time taken by the faster vehicle to catch up with the slower vehicle. So, time of catching up. We are going to use this. The formula time is given by distance apart, or relative distance, divided by relative speed. The distance apart is 45 kilometers. And the relative speed we found to be 30 kilometers per hour. So this one gives you 1 hour, 30 minutes. When you press on the calculator, it says 1.5 hours. That is 1 hour and 30 minutes. So, the question wants us to find the time. At what time will the bus catch up with the matatu? So for us to know what time the bus caught up with the matatu, we are going to take this value, we add to the starting time of the bus. The starting time of the bus was 8:30 a.m. So when you add this calculated time here to this value here, we are going to find the time the bus caught up with the matatu. So the answer here you are going to take 0830 hours plus 0130 hours, and that gives us 00. When you carry 1 here, you are going to get 10. So this one is less than 12, meaning it is still AM. So the time of catching up is 10 AM.